Git and GitHub for beginner web developers using Visual Studio Code. If you're a web developer or you'd like to learn web development, this is the only video you will need to get started with Git and GitHub. You will learn the basic Git commands, you will learn how to stage, commit, unstage, stash, and so on. You will learn how to branch off, how to merge branches, and we will also synchronize our Git repositories with our GitHub repositories. So you will find out how to push, pull, and clone, and at the end of the video you will figure out how to build a resume or an online portfolio just by cloning someone else's repository and changing the text and the images. This way, by the end of this video, you will have a professionally looking resume or portfolio site. Let's jump right into the basics. So here you can see Visual Studio Code. I just opened it with File, Open folder, and I just moved into a Git tutorial folder. Before getting started, make sure that you have Visual Studio Code installed from code.visualstudio.com. I will show you how to get the installation. So here we have code.visualstudio.com. Given this is a Windows computer right now where I'm recording, it just gives us a download for Windows stable build. So that's all you need. Download it, install it, and you're basically done. If you have Linux or Mac, you will find the proper download button in here. I assume you came here to learn about Git and GitHub because you already have an idea of what Git and GitHub is. But if you don't, then go to gitscm.com, or if you haven't downloaded Git, go to gitscm.com. SCM stands for Source Control Management. Read or watch the basic videos, tutorials, why Git is so good, what it means to have decentralized development, and so on, so that you can get started with what Git is. I will just give you a short summary of what Git and GitHub are. So Git is basically a decentralized source control management system where you can track your changes as you develop your websites or web applications or other sort of code if you intend to use Git, not for web development purposes. To install Git, you have to click this download 2.26.0. Your version might differ if you watch it in 1 year, 2 years, 5 years from the recording, but the idea should be the same. Find the download button and install it. It should not be problematic for you. If it is, write it in the comments and I'll upload a new video about it. If you have Windows, there is something else I can recommend for you. gitforwindows.org. A Git shell or a Git terminal that will help you with some basic Git commands. And with this, you will be slightly more productive. So it comes with this thing called the Git Bash. I will make this a bit larger so that you can see it better. So Git Bash, it's some sort of a terminal that mimics the functionality that you have with Linux terminals or Mac terminals. And we have this Git GUI as well and the Git K that also give you some more information on Git commits and so on. So if you want to install that, you can download it. You don't have to use it, but it helps. And after you go to the download button, it just installs, for me, the 64-bit version, but for you it might be different. Now that we got the installations out of the way, chances are that you have to restart your Visual Studio Code as well after you finish the installation. Just close everything in your Visual Studio Code. So when you have a new Visual Studio Code open, there are some basic notes that you might have seen before, and if you close it, then you see all the commands. And one of the commands is toggle terminal, this control and the single apostrophe, single quote. So if I do that, then you can see that it opens the terminal. If I press this combination again, then it closes the terminal. If you don't want to remember or press these combinations, then you just go terminal, new terminal. I don't know why they added the shift as well. Maybe it's because it's a new terminal and it's not toggling the terminal. But opening the terminal should not be that difficult. And here you can see that this terminal is basically the Windows command line. So if you have, for example, Total Commander or any other tool, then I can show you how to open the same terminal. So here we have this Total Commander, which you might research and install if you have Windows. It got stuck with me since the 90s or so, because back in the days when I started programming, there was this tool called Norton Commander, and back then there was only this operating system called DOS, and Windows 3.1 was quite new to me and it was not that useful. So when I navigated in between folders, I just used this total commander. It's not a big deal. If you want to install it, then you go to this gizler.com and grab your version. So it's all fine to do that. You don't need it necessarily. If you open your start menu, which is on the top right for me, then type here to search, and then you type command for command prompt, and it just opens the command prompt for you. So it's the same terminal as well. So there are many ways to do this. I will refer to this total commander a bit later for demoing purposes. So if you don't want to install it, don't bother. I'll just show you once you create a Git repository what it looks like from the inside, because we can inspect it very easily from the total commander. So that's all I'm gonna use in there. And also you don't have to open a terminal like this or a command prompt, because we will use the terminal of Visual Studio Code. In Linux and Mac, possibly you know how to open a terminal. If not, then your best bet is to just type into Google how to open a terminal on Mac. And there you go. Basic commands and functions and so on. You see, it's very easy to find it. It's just the first article oftentimes are just sufficient. So basic Mac commands in terminal and so on. So there is also an opening, there is everything else you need to get started. It's very unlikely that you will need to research that, but if you do, then go ahead. Most important thing is that here we have this terminal. We have the CMD for the regular command line, but I also told you that it's also possible to install, for example, Git Bash. If you want that, then press Ctrl-Shift-P, and we have this terminal, select default shell. So once again, it's Ctrl-Shift-P, possibly on Mac it's Command-Shift-P. And then you can select between the different terminal types. We're gonna just use the Git Bash. It doesn't change anything yet in the terminal, because it keeps this regular terminal open. But if you press the plus button next to it, then there is gonna be a new terminal created. And the type of terminal that's created is the one that we selected. So this is the Git Bash. I'll show you another one, another type of terminal, select default shell, which is the PowerShell. This PowerShell is something Visual Studio Code gives you. New terminal, and there you go, here is the PowerShell. We're not gonna use this PowerShell though, because it comes with some different settings. When I teach, for example, Python, there are some things called virtual environments, and they are also present in there, and they might just confuse you a bit. So we will not use this shell, but if you would like to follow along using the PowerShell, you can do it without a problem. So now we learned how to launch these shells in Visual Studio Code. And technically, you don't need a lot of shell knowledge to get started with Git GitHub, because Visual Studio Code also gives you Git access. So you can even click this Initialize Repository button and it will initialize the Git repository for you. So you could technically get away with just using Visual Studio Code. But it's always better to know what's going on in the command line, especially that when there are new features coming to Git, then the first thing is gonna be the command line that's updated. So before starting the repository initialization, let me just walk you through some basic commands. For that, we're gonna go back to the Explorer. So either MD or mkdir creates a folder or directory depending on your terminology. So folder or directory, it's something that contains other folders or files. So if I press mkdir and let's say styles and press enter, then you can see on the left that the styles folder appears. So now we have a style folders inside. In some operating systems it's md styles, but you can see that, well, technically it works in this terminal. So if I press md styles 2, then it would create the styles 2 as well. So both mkdir and md works on Windows, but on your operating system, maybe just one of them. Now, if you want to clear the screen, then there is this command called cls, which may or may not work. Here it's working. Now, if you're using Git Bash, for example, you type something that doesn't make sense, if you type CLS, it's not gonna work. You see CLS command not found on Git Bash. There you need to add the clear, and then it clears the screen. So depending on your terminal. And then I will soon highlight the main difference between the command line paths and the bash paths. We can navigate between folders with a CD. CD stands for change directory. So we're going inside the styles folder. Alright, now we are inside the styles folder. You can see the path. C, that's the drive. That's the hard drive where you're on. WebDev, that's just the folder / Git tutorials. So this means that there is a WebDev folder inside the C drive, and there is a Git tutorial folder inside the WebDev folder. And then the same holds for the styles. You can see that there is a folder like this. You can also add absolute paths. And in the latest Windows versions, you don't have to use backslash. This is the backslash. You can also use slashes. You can use webdev / git tutorial / styles, and then you went to styles, but you can also go to styles 2, and now you see that we went to styles 2. The slash represents the root, and then the rest is gonna be hierarchical. So go to the root, which is here the C drive, then go to the webdev, then go to the Git tutorial, then go to the styles 2 inside the Git tutorial. So this is how we can change the directories and navigate in absolute terms. We can also go one folder up with cd ... See, we went one folder up because from styles 2 we went to Git tutorial. And whenever we are somewhere with dir, we can list everything we have. So it's very much like a fighting fantasy book or a choose your adventure type of book where you have different places, and then you can make a choice on where to go. The dot is the current directory. The ... is one directory up, then you have the styles, then you have the styles 2. So you can go to these four places. cd ... will just leave you where you are right now. cd ... will move you one folder up, and then you can choose any of the styles. For example, we go to styles. This dir may not work for you. If it's not working for you, for example on Linux Mac, then use ls instead. ls is not working here, but it should be working on Linux and Mac. By the way, in the Git Bash, dir is working fine, but the output is different. Here you just see the folders, and it just assumes that you know what dot is and what ... is, so it's not gonna give you these options, but you can still do cd ... for example. Here, if you try ls, it's working as well because it tries to imitate the Linux functionality. So dir or ls, these two are working. The absolute paths are not working in the same way as in the other terminal, because if you added like cd / webdev / git tutorial, and now I'm just typing tutorial, then you see that there is no such file or directory. This is because Git Bash imitates Linux and Mac. So in Linux and Mac there is one root. In Windows there is one root per drive. So you see here, for example, this is the C drive. And if you type, for example, D : or E : then you would go to another drive. So here we went to the E drive. C : we went to the C drive, and our original choice of folder is remembered. This is not happening in Git Bash, because the drives like C drive, E drive, and so on are symbolized by these folders C, E, and so on. So instead of this webdev git tutorial, you will have to do cd /c/, and you can already see that it's working because if you press the tab now, it auto-completes. And also I just type git and press tab and it auto-completes. And let's say st, and here it auto-completes to styles, but you can obviously write a styles 2. So here we are going to styles 2 like this. If you want to go to styles from styles 2, then you just do cd ... /styles. This is gonna be important once we create HTML files and reference CSS files, for example, because we will do relative references for now, because we are not running a web server here. Now that we're done with the basics, let's just initialize our Git repository and also configure our Git repository. First of all, let's check if Git is installed for us. Git -- version, done. You see that I have an earlier version installed because I demoed 2.26 and here it's 2.21. It's not a big deal. I could just download the same file and install it, gitforwindows.org, or I can also do git update git for Windows. And then I press enter and this is gonna update Git for me. And you see that update 2.26 is available. So of course I'll ask for it and it's gonna do some downloading. It takes some time because it's not just a very small update, it's relatively large. So once everything is downloaded, the installation is going to be performed. Now, Git Bash is closed because Git Bash belongs to Git for Windows. And when we update the version of a software, we usually close that software. This is why you saw Git Bash closed. And now it's installing itself and possibly it's gonna be ready. So this is why we have this terminal process terminated with exit code, because it has to be closed. Now we still have the installation, so here we accept everything, install, and it's basically the same thing as downloading the Git for Windows file. But if you're lazy to go to gitforwindows.org, then you just type this in the terminal. And you can see the installation going on. I made it faster for you. After it's ready, we have a relatively fresh Git for Windows. And then after the installation is complete, we can repeat basically the same thing as what we did before. So we'll change the default shell to Git Bash and we'll create a new shell. So installation is done, registry entries, uninstall, and so on. There were some release notes sent to my other screen, so you see known issues, new features, and so on. So you can see what happened since 2.21. They always update Git, so you see that in every few months or so there are some changes. So for example here they created some changes and so on. So these are the release notes. Now let's go back to the Git Bash. So select default shell, Git Bash, we're gonna select that, and we're gonna create a new bash. And let's see git -- version. It should be, yes, it is now 2.26. So our Git is installed and it's also updated. Now, the next thing that you will want to do is, if you have a GitHub registration, or if you don't have it yet but you have an email address, then decide what email you're gonna use with your GitHub. So GitHub is basically a web interface for Git, and this is where you're gonna store some of your repositories, and GitHub also gives you an option to host some websites. For example, it can host JavaScript files and a lot of other things. For the configuration, we will need git config -- global, and let's start with the email. User.email. So now decide which email address you're gonna use for GitHub a bit later once you go to the registration. I'm gonna use this. So there is gonna be this email address set. There you go. In terminal world, no news is good news. If you don't see something like fatal, then this means that everything is correct. So the configuration option is set. Now, there is another setting called user.name. We don't have to add the quotes, by the way, for the email address because it doesn't contain spaces. But for the username, if I add my full name like this, then you have the full name set. You can also list your configuration options. So git config global list. And then you see our global settings. There is my name, email address, merge tool, whatever it means, and some path for this merge tool. We already talked about this, that we can initialize a Git repository from Visual Studio Code, but we will do that initialization this time from the terminal. So we will have to do git init to initialize the GitHub repository, and it just initialized the repository. And you see that the initialization was done. You can see this blue master appear. This is something we call a branch in Git world. When we develop software in Git, there are multiple branches where we can do development. I will illustrate this a bit later. Master is a dedicated branch, that's the main branch where we develop. A branch, you will see later, it's nothing else but a label on a tree-like structure where you have commit after commit after commit, and one of the states are indicated by master. Let's see what this created Git repository looks like. This is actually quite tricky, because if you check this Git tutorial folder using your Window Explorer or Finder or whatever other tool that you're using, then you can see that there is just the empty styles and styles2 directories that we created before. And this is why I showed you Total Commander before. Total Commander right now configured as show hidden files and folders. You see a .git folder inside. And this .git folder has an exclamation mark showing that it's basically a hidden folder. You can see it with larger icons, so we have styles, styles2 and the .git. And inside this .git there are quite a lot of things. These give you everything you need to administrate your Git repository. It marks all the changes and everything basically associated with your repository, your branches, your commits, and so on. If you delete this, here in Total Commander we're just deleting with F8, then after the deletion you will see that I refresh the terminal and the master branch is gone. In fact, the Git repository is completely gone. And here we went back to the state initialize repository because it's not initialized anymore. The Git folder is missing. So this time, instead of adding Git init, I'll just press the initialize repository. It will do the exact same update, so it initializes, and here we have the master branch again after the initialization. So same thing. If you add another parameter after git init, so here we create, for example, git init portfolio page, we can do that. So in this case, we just create a portfolio page folder, and then we initialize the Git repository inside the portfolio page. So you see that portfolio page was created, and .git was created inside the portfolio page, and you can also see this portfolio page appear here. We don't need this now. I just showed you that it's a possibility. If we delete it, we just remove this portfolio page repository. We have our repository, and by the way, we can also clean things up because, for example, we don't really need these styles and styles2. For now, I'm just gonna delete them because we really don't need them. Let's get started by creating an index.html file. This is usual because when we do HTML development, we just start with a main file. You might think, oh, now I have to write HTML and I have really no idea what we need. We have this HTML head and body and so on. No problem, there is Emmet coming to the rescue. So you just type HTML and you see these are Emmet abbreviations. HTML:5, you select it and everything is generated for you. See, you might want to change this title to, for example, portfolio site or whatever you would like to do. And now let's add the main title. We do it with Emmet, H1 and enter. It creates a heading 1 tag and we add portfolio site. Same thing. We can also add some paragraphs, portfolio site. And save. Before saving, I'm showing you that there is this dot in here in Visual Studio Code. This indicates that we haven't saved. Saving is done either with Ctrl+S or Command+S, depending on your operating system. If you don't have a command button, it means that you're not on Mac, so don't worry about it. Here we have save Ctrl+S. Focus on this dot, and I'm gonna do Ctrl+S, and you see that the index.html file is saved. Now let's see what's in the Git repository. In Git Status, you have this index.html in red. If you go to the Git, you also see index.html changes are to be done. In Git, we have this concept called the staging area. A staging area contains some changes that we would like to commit into the Git repository. Whatever files are in the repository are gonna be stored and they are gonna be retrievable. And you can also travel back to the past using it. Right now, this index.html is not tracked. We can track it by doing git add dot. It would add everything in the current folder, but we can also type git add index.html, and if you just type int and press the tab, Git Bash auto completes it for you. Also, your terminal on Linux and Mac will do the same. So let's run git add index.html, and you see also on the left that your changes went to the staged changes area. So this is the staging area. If you do git status, you see that the same file is now green. These are changes to be committed. You can unstage as well. So you see with this minus you unstage. And now if I enter git status, you can see the same thing as what's on the left. So index.html is now red. You can stage again. You can also just press the plus button to stage, by the way. So you don't have to use the terminal. It just comes handy if you know what's going on. And you know, I said this is the only tutorial you need if you want to get started with Git and Visual Studio Code, so why not do everything? Git status. So you see the file is ready to be committed. Let's see what we can do to commit this file. Git commit is the command, and now we can add git commit -m and created index.html file. Some commit message that you would like to see in the commit. And you press enter. And you see that this commit succeeded, one file changed, 12 lines got inserted because we have 12 lines in here in total. So we created this index.html file and it's now in there in Git. And you see that the file index.html got removed from the staging area because now we have no changes. So clear, and if you do git status, nothing to commit, working tree is clean. Let's go back to the file explorer part of Visual Studio Code. So this is the explorer. And now let's create a CSS file. So I'm gonna just create styles.css and let's do some things. For example, for the heading ones, let's change the font size to 72 pixels and the color blue or whatever. And by the way, if you want to change the color, Visual Studio Code helps you because you have this color chooser tool and you can create some good looking solid blue color. You can even change the transparency. You know, 0 is fully transparent, 1 is not transparent at all as the fourth parameter. And once you're satisfied, you can just exit this tool by clicking elsewhere. So this is our heading 1 color. And for the paragraph, let's make the font size, for example, 18 pixels. And then we're done. This is the styles.css. Now, this styles.css is not yet taken into consideration. So if you check reveal index.html in File Explorer, and then just double click to launch it, or drag and drop it to a Google Chrome window, for example, to launch it. I'm just going to double click it and show you the file. So the file looks like this. This is the portfolio site right now. The styles are not taken into consideration. This is because in HTML we have to link the CSS, and Emmet comes to the rescue again. So you just write link, you select the one that you want to link. Here we want to link a CSS file, so we select that. And it's not style.css in the href, but styles.css. And we save with Ctrl S. And now if you check the portfolio site again, so we can drag it back here. And now you can see the title is blue and the font size here is correct. So we are done with this portfolio site. Now we need to stage and commit. You see that there are 2 changes in Git. And you see 2 files are in the staging area. You can open the file and review it. So for example, I click here, you can review what changed. You can discard the changes, or with plus, you can stage the changes. I'm going to show you the staging in the terminal. So maybe let's make the terminal just a bit smaller so that you can see it better, so that more things are on screen. So git status. You see that index.html got modified and styles.css got added. We can just do git add and dot. Now here you see this warning CRLF got replaced by just LF. Why is that? Git is a distributed version control system. It can be used by Windows, Linux and Mac users, or whatever operating system you're using. And this means that even though on Windows we have this carriage return and line feed characters that symbolize a new line, on Linux you only have line feed. And the consensus is that in a repository you don't really want to track changes just because a Windows user saved a file, because then every single line would be changed each time someone saved a file, because the line feed would be replaced by carriage return and line feed. This doesn't make much sense. The version control history will mark every single line as changed. We don't want that, so the uniform consensus is that we only use line feed in Git, and therefore we have to convert these files to use just line feed. So staging area is set. You see that these two changes are staged. We could have just used the plus buttons one by one to stage them. And now we can do commit. So this is our second commit, by the way. We could do just git commit -m and the message, but we're not gonna do this now. We're gonna use Visual Studio Code to perform the commit. All we need to do is add the message. So styles.css is created and linked to index.html. So this is the commit message, and with the check mark we perform the commit, and you can see that it's done. Now Git Status shows you that the staging area is empty. You might ask by now, where are these commits? What is going on? So let's see what's going on. We have this command called Git Log. Git Log shows you two commits. I created these two commits, one here and one here, just a few minutes after. And there are the messages as well, created index.html file, and style.css is created. This long thing is called the commit hash. I think it's 40 characters long, but I'll have to double check it. So you can do this with JavaScript, by the way. I'll just place the developer tools in here. By the way, on a website you have this Google Chrome developer tools. I have it in dark mode, it might be in light mode for you. And in this developer tools you can have access to JavaScript. So any JavaScript you can execute. So this is a string in JavaScript. This is one of my commit hashes. And .length gives you the length, it's 40 characters. Now, this commit hash is 40 characters, and the possible characters are 0 to 9 and A to F. These are 16 possibilities. This is called a hexadecimal number, by the way. Hexadecimal, because hexa is 6, decimal is 10, and it's base 16. It's like 9 plus 1 is A plus 1 is B plus 1 is C, and so on, and F plus 1 is 10. So this is how it works. It's just like our number system. Why is this important? It's important because we have 16 to the power of 40 possible combinations for these commit hashes. This is like a 1 and 48 zeros, and multiply this by 1.46. This is how many possible commits we can have. So the probability of clashes that two commits will have the exact same hash is so low that it's basically negligible. Even if you just use the first 7 characters of this, so like this, or first 6 characters, 16 to the power of 6 is that many combinations. So you will need to have commits in the area of 10,000s, 100,000s, millions, rather like 10,000s, 100,000s, that if you just use the first 6 characters, you cannot uniquely identify these commits. So even just by using the first character, we can identify the commits. But in reality, it's not possible. You have to use at least 4 characters, I think. Let's see. If you use git checkout, you can check out a branch or a commit. So if you use E9C, then it's not gonna work, I think. Yeah, it's not working. But if you use E9CA, then you see that we went to this commit E9CA181. So this means that we went to this branch. You can also use Git Switch, as this command says, and you can create a new branch name. So you could just use this branch name to refer to this commit. Let's go back to the master. You can do it git checkout and master. So this way you went back to the master branch. The checkout is what can check out a commit or a branch. We saw the git log. It's kind of verbose. So you can also do git log --one line to just give you a shorter representation of the same thing. Here you see the E9CA181. It's the same commit as that one that we checked out not too long ago. And you can just see the first 7 characters because you don't need much more. By the way, this head is a pointer to where we are right now. It doesn't have to be on the master branch. So you can also go to the previous commit. So you can also do git checkout. And here we wrote E9CA, but we're not going to do that now. We're going to use an abbreviation, because if you want to reference how many commits we need to go back with respect to the head, you can do this with a tilde character. So you have head, and here you need to press a tilde. For that I need to change my keyboard layout. So tilde, head, tilde 1 would result in 1 commit before where the head is. And you see that it's E9CA. So let's go back to master. And before going back to master, so before pressing enter, let's just see, in the previous commit, we just see the index.html. We cannot see the styles.css because it got deleted, you see? So styles.css is not there, just the index.html. And if you check out master again, then the styles.css is there again. If you want to see what the changes are with respect to the previous commits, you can use git diff. So you use git diff head ~1 head. It means let's go back to the previous commit and let's see the current commit and what got changed. And you see these things got added. You just press down and you see that we created a link and we created the H1 and the P. With Q you can exit this git diff. So this is convenient. If you change head and head ~1, then you look from the present to the past. So it's you're in the present with head, and with head ~1 you go to the past. So this means that these things got deleted. And by the way, you can also do the same thing with head ~2, but there we don't have anything that's identified as 2 commits before the last commit. So this means that you get this fatal error. Let's make some changes to the HTML file. Let's add some changes to the CSS file as well. For example, let's introduce REM metrics. REMs are relative EMs. EMs are used in typography. It's a relative unit. And oftentimes we just style our code in a way that you have the HTML element, you fix its font size, and every single relative EM element is just the function of the font size of the HTML. So you multiply the font size of the HTML element by the REM metric. So 48 pixels will become 4.8 times 10 pixels. 10 pixels are in the HTML, 4.8 are in the H1 REM settings. Let's add these changes with git add ---- patch. And now we can review the changes one by one and then stage them. With a patch you can see what is changing, what is not. And after the review, you just write git commit -m, HTML and CSS changes, and we're done. Let's see the log. You can also add git log --one line graph to get a sense of what the Git looks like in a graph format. Later it will be more interesting than just a line, a linear graph, but we're not there yet. Let's make a change to the index.html and check the Git status. Don't worry about the changes, we're gonna delete them anyway. Stage them to the HTML file. We can unstage the changes by writing git reset head and then the file name. For example, index.html. You can see in Git status that index.html is red again. And if you want to get rid of the index.html, then you can just write git checkout ---- index.html. After typing git status, you can see that the working directory is clean again. Let's now learn how to remove files. So first let's add the commit. For example, we can have a readme.md file, and after creating the readme.md file, we can stage and commit. By the way, this readme.md file is written using the language Markdown, And this is a very good language for documentation. In this step, we're not gonna get into the details. We just accept that this is gonna be the documentation file. And now let's commit the changes. And now you can see that there is a readme.md file in the repository. Now, if you want to delete it, you could just go to Visual Studio Code, right-click on the file and delete it, or you could go to your file system and delete it as well. But the problem with this method is that Git is not tracking what is deleted automatically. So if you want to synchronize your deletion with Git, then the suggested way is to use the command git rm. Rm stands for remove, and you just write git rm readme.md, and then after checking the status, you can see that the file got deleted, and this deletion is moved to the staging area. And whatever is on the staging area can be committed, so we can just commit removed readme.md and we're done. We learned before that there are these references like #1, #2 and so on. So let's pretend that we still want the readme.md file and it just got deleted. So in this situation, what we can do is check out the previous commit with git checkout #1, and you see that our previous changes are in the source control. This is why source control is useful, because sometimes you make changes that you want to discard, or sometimes you want to make changes in one branch that you need in another branch. So all these changes are tracked by Git, and you can get to any point in history in development that you want to revisit. You can even reorder the past, more on it later. For demonstrational purposes, we can just save the current master state. So if you write git checkout -b save current state just in case, then we're gonna have this current state available. So this current state on master is the state where we are on. You can see with git log one line that both master and this save current state point at the same node in the git tree. Now let's check out #1, so this is the previous commit, and if you write git checkout -b with capital B and master, what you're gonna do is move the master node to that previous node. This way you reverted master to the previous node, and you can continue development from there. So this means that we reverted the deletion of the readme.md file. If you check the git log, you can see what's going on. So master is at the top. And if you check out the save current state, then you can also see that that branch is still there. That's one ahead master, and it's gonna stay like that because we're not developing it. We could technically discard that branch as well. So you can write git checkout master. And as you can see, if you write git branch, we can list this current state. And actually, if you don't need that branch anymore, we can even delete that branch. So we can do git branch -d with capital D, and then the branch is deleted. And then if you list the branches, it's not gonna be there anymore. By the way, don't worry about deletion of branches. So if you still needed the change, you still needed the last change that deleted the readme.md file for any reason, you can just type git reflog, and inside this reflog you can just identify the commit that belonged to the save current state just in case branch. Technically we didn't even have to create this save current state branch, because even without it we could have gotten the change back, but I created it just for the purpose of demonstrating that everything is, first of all, everything is safe, and second, that branches can save progress, because this is an alternative path, an alternative branch, and that branches can be deleted. Let's pretend that we want to move the styles.css file to the CSS folder. So right now styles.css is in the root, and we can just move it. So let's create the CSS folder. We can technically drag and drop the styles.css file to the CSS folder. That would work, but let's remember what we did during deletion. We would like to inform Git that a deletion is gonna happen, and we would like Git to administrate that in its next commit. We can use the command git mv to do that. So we write git mv styles.css css/styles.css. If we do that, then the moving is going to be performed. And let's see the changes. So in the staging area, you can see that the changes are there. And then we can just commit the changes, git commit -m, and the commit message. And we're done with the moving of files. Let's not forget about updating the reference in the index.html file, otherwise the changes would not work. So we have css/styles.css now in the link. And let's stage and commit the changes as well. Now it's time to create a gitignore file. Gitignore is a file that tells us what files to ignore and what files not to place in version control. So for example, if you have some secret configuration that you don't want to share with others, and you haven't learned how to store secrets properly on your server, for example, then you could also create a configuration file. You create a sample version of it. For example, you write account-sample.js, and then you write just the template of what you expect in there. For example, we can write const API key, enter your API key here in account.js, and then export default API key. You can do that, it's not rocket science. And then here you just share your expectations with the other developers. And let's suppose you create an account.js as well, because you would have to rename the account sample.js to account.js, or just make a copy of it and provide your real secret. For example, your real API key, secret sequence of digits, hexadecimal digits, base 16. Just like the commit hashes, we could actually use a commit hash as an API key. Doesn't really matter because you normally get it from an online source. When you register for an API that you want to use it, you usually get a key. And then the server can track how many times you use the API and they would charge you accordingly. So this is why you might not want to share your API key. And if you want to make sure that this account.js file doesn't end up in version control, then you can just create a gitignore file. And let's see what we write in this gitignore. So first of all, we can ignore the file account.js. That's easy. We just write account.js. You can add a slash in front if you want to specify that it's in the root folder. We usually ignore another folder called node modules, because you will see in web development that usually we have a package.json file, and in that package.json we have some dependencies. And whenever you write npm install in the terminal or npm I, then these dependencies are going to be installed. The problem with these dependencies is that it can take like 100 to 200 megabytes or even more in case of a large application to store these dependencies, and for this reason we don't want them in version control. All we want is to specify what kind of versions of which dependencies we install, and the package.json can do that in just a couple of 100 bytes, instead of those megabytes or even more that you would have in your application folder. So typically node modules only belongs to your own computer, and therefore we can write node modules, node_modules slash, to specify that we don't want to see this folder in version control. And then let's say we have these original files as well. We can also write patterns like *.orig. So let's see git status. These are the files changed. You can see that the account.js is missing thanks to the gitignore. Now let's stage git add dot and git commit -m. And after we are done, we have a gitignore successfully set up. Our next topic is Git branching. In version control systems, especially when multiple developers develop an application, usually we develop features in branches. And this way, you can start developing two features in parallel based on a common master. So let's suppose that you have a longer development. So for example, you would like to create a shopping cart or something longer term, which will take you days. But when you're right in the middle of development, you get a bug report from your client, and that bug has to be fixed immediately because the client is losing money. In this case, if you're in the middle of development, what makes the most sense is just find a way to save your current changes and then go back to the previous master, which contains the state, exactly the state that your client can see, and then develop the patch And after the patch is developed, you can resume your development in the other branch afterwards, and you can also include the bug fix in your other feature. So this is what we're gonna do now. Let's create a branch feature about page. You can do this in one command and in two commands. I will show you both. So in the two commands way, you do git branch feature about page and then git checkout feature about page. This is the two command way. The one command way would be git checkout -b feature about page, which would do both the git branch and git checkout for you together. We will do some development in the feature about page. We will create an about.html. We use the help of Emmet, and we're gonna also add a heading 1, plus place the styles.css reference in the head. And then let's commit the changes. But this time, given that we are on this feature about page branch, the commit is gonna go to the feature about page branch. Let's now take care of our bug fix that the client supposedly just reported. So let's suppose that the client wanted to give us this very important, very urgent change. So let's check out master, and for this bug fix as well, we can create another branch. So this branch is gonna be git checkout -b, and after that we just add either feature or bug fix, doesn't really matter, and then we add the description as well in the branch, and now we're on that branch. We will develop that very important feature, and after we're done, we commit it, and now we have a longer feature branch and also this client request. Let's quickly get rid of the client request so we can merge this change into master. Given that master is in the history, this merge is a so-called fast forward. In case of a fast forward, all we do is we advance the master label to the current commit. We can do this, it's very easy. And now you can see that the merging is done. This was an easy merge. Now, if you check the log, we're on the feature branch. By the way, you can also use this git k. It's not too good with accents. So if you're using a language where you have these accented characters, like for example, ö and ü and so on, then chances are that git k will not display it for you. But otherwise, if you just use regular English characters and don't use too many emojis and longer characters, then this should be just fine. And you can see the log as well in a slightly more graphical format. And there is also the git GUI where you can stage and unstage. I used to use this git k back in the days in Linux in 2013 or so. Since then there have been better tools, but bear in mind that you can use this git k also in Windows, because the git4windows.org package gives you git k as well. Let's continue developing. For example, we can place a paragraph at the bottom of index.html. This will even conflict with the latest changes the client requested. That's gonna be fun times quite soon. So we added this paragraph, and after that we can do git add, git commit, so we stage and commit. And now let's suppose that we want to go back to master and merge it. The problem is that if you check git k, for example, or the git log, you can see that master is not in the history of the current branch anymore. So this means that we cannot do a fast forward anymore. And this also means that we need to update our branch before merging back into master. So here we have some diverging histories. You can see that there is one commit where master is because of the client request. And there is another branch where we have commits. And we need to take these commits and advance the master branch accordingly. We can do this in two ways. One way is merge, and another way is rebase. Merging is when you have two branches and you create a third commit that has two parents. One is the last commit of the first branch to be merged, and the second is the last commit of the other branch. So if we do this, let's see what it looks like. So we have git merge master from this other branch, because now we are updating our branch with the latest changes of master. So we do git merge master, and then you can see this conflict. Visual Studio Code is very helpful in resolving conflicts because it highlights it in green and also in blue. So you can see which change comes from which branch. You can accept the current changes. You can accept what came from the other branch, so from master, or you can accept both changes, or you can even accept a third version. So it's fully up to you. You can even see the changes, what's on the left, what's on the right. Visual Studio Code just gives you everything you need. By the way, a merge conflict is symbolized by these greater than symbols, less than symbols, and equation signs. So you could just edit a text file and get rid of the conflict yourself. And after you're done, you just add the changes with git add. Well, the merge is also a commit. So after you commit it, you can see the results. Let's see git k. So in git k, you can see that now we have a commit that is the child of two other commits. One is in your feature branch and the other one is on master. So this is what a commit looks like. If you don't want to use git k, then you can just go to your terminal and type git log one line and graph. And you can see the same graph where each commit is summarized in one line, and you can see which branch is coming from where. So this is the merge situation. In case of a merge situation, you have a history that is not fully linear. So not fully linear in a sense that you have a left branch and the right branch, and these two branches are merged. This is great if you want to do something fast. So for example, you want to do the merge of two long histories and you want to resolve every single conflict at once. If you do this too often though, then you can imagine that your tree is going to become a mess. So you will have many different branches and then they are going to join. It looks like a larger railway station where you have all these branches and merges and so on. This is one reason why rebasing would make sense. So rebasing is the other way of resolving a conflict. The other reason why rebasing makes sense is that we can fully read a linear history, which means that every single change is in one line. And there we have a clear order of what comes after what. So this way you will be able to track the history of how the master branch developed. Let's see how rebasing is done. We do the same thing as with merge. And in fact, we can do this even after merge. So if you add the git rebase master instead of git merge master, or after git merge master, the result is going to be the same, because eventually the rebase is going to override the history. When we do rebase, we change the history of our branch. So, some people can also change history by emphasizing a false narrative rhetorically. We can do the same in Git, even though the narrative is not false in this case. It's just the sequence of events are going to be false. So we can add git rebase master, and after that you see that the same conflict is going to be resolved. We can resolve it in the same way as before, and after we are done with the resolution, we have to write git rebase -- continue. You might have multiple steps, multiple conflicts, and in fact the rebasing process typically takes longer than a merge process. In this case, the reason why we just have one step is that our changes were easy. There was just one conflict once. But if I had, for example, two commits, then you would see two steps for the rebase. That's not a problem. But if I had two commits belonging to that paragraph, then you would have two steps in the rebase. So then after git rebase -- continue, you would see another conflict, and then you would have to resolve it again. While in merge, you would have to just resolve the conflict of the two end states. This is the difference, and this way rebase gives you more information, and rebase is therefore a bit more bulletproof, because it makes you think about the same change multiple times. If the change is easy though, then the problem is that it soon becomes quite boring. So after we're done, you can see that rebasing is complete. And the changes don't even have to be committed. We're already there, and you see that the history got changed, the rebasing history, and you can see the order of commits on screen. This was the rebase scenario. After the rebase, you can see that master is in the history of the current branch, and the branch is completely linear. This means that we can fast forward master. So for that, let's check out master, git checkout master, and then if we type git merge and our feature branch, or git rebase our feature branch, they're gonna be fast forwards. So we just fast forward master. If you prefer seeing multiple branches merged together, you can do that too by doing the merge with the no fast forward switch. So you write -- no -ff or -- no -ff, depending on what you call these minus symbols or dash symbols. And by the way, you can take care of deleting the branches if you don't need them anymore. So you can list the branches with git branch, and you delete them with git branch and the D switch, the capital D switch. Let's now practice a bit of stashing. So let's make a change that we don't really need for now. This is like adding a paragraph, and let's pretend that we haven't even had a branch or anything. This is just an experiment. So for example, we can measure how much time something takes. For example, in JavaScript with console time and console time end, that's a good example. And this is just experiment. So we're experimenting, but we don't want to throw away our experiment, but this experiment is not worth for a branch. So this is not development, this is just for us. This is a good example for stashing the changes. The stash is a data structure that's called a stack. A stack, it's like you put something on the top and you look at it from the top as well. So this means that you can only access its top element. It's like last in, first out. The last one that's in is gonna be the first one that you can take out. This is the structure, so you can stash the changes like that. We can also stash another change on top, and then you can see in the git stash list that you have two changes in the stash. Technically, it's not a stash data structure because you can access multiple elements in the stash, so you can access them by name as well. So in theory, it's not a stack, but if you just use the git stash and the git stash pop, then the git stash pop just gives you the top element back. So after writing git stash pop, you can see that the last changes appear in Visual Studio Code. And obviously you can also follow what's going on in Git Status, so all the changes appear there as well. So we have git stash pop, git stash list, and of course you can also delete the top element using git stash drop. We now have an index.html and an about page. We can link the two, so we can add anchors in index.html to about.html, and we can also add an anchor to about.html in index.html. So let's go to the about page and add the link to the index.html. Let's commit it, so stage commit. Now that it's done, let's go to the index.html and let's add the link to the about.html, and let's stage and commit the changes as well. Now that we are done, we realize that we have two commits, but this is technically one change. And well, why do we have two commits if we could just have one? How could we squash these two commits into one? That's the question. And for that, soft reset works really well. So with soft reset, you can very easily just get the changes in the staging area. So it's going to be back in the staging area. And you specify how many commits you want to go back in history. So let's do git reset -- soft, and then you either add the commit hash, so you would do git log before and check out what the commit hash of the previous commit is. So you either add the first few characters of the commit hash, at least first 4, but possibly more, so usually we just use 7 characters. Or if you know that it's the last 2 commits, then you just write head tilde 2. So let's do the reset there. And And then if you check the status, you see that all the changes are staged and they are ready to be committed. But this time it's gonna be one commit and not two. So we commit and we can add a different message as well. By the way, if you didn't want to commit, you can just delete everything from the staging area by either unstaging them and then check out --, or you also learned how to use a stash, so why not just stash the changes and then git stash drop. That works too. So let's do this. So now we're getting rid of these changes. So let's do this stashing, for example. This is a good example. And by accident, we just got rid of the changes. And now you might think that there is no way back, right? Unless you remember that there was this git reflog command. With git reflog, we get the commit back, and with merge, git merge and the commit hash, we can get the two commits back, and master is gonna be updated. So if you remember, now we're on the stage where we still have the two links in two separate commits. So no damage was taken, the reflog saves us normally. And this was even an automatic fast forward merge. So let's go back to the Git Reset soft. We went back to the stage where our two commits are gone, but they are still in the staging area, and then we can commit them as one. By the way, there are three types of resets in Git. One is soft reset, you have seen that already. The second one is a mixed reset, and the third one is a hard reset. You can see the visualization of the three types of resets on screen. So let's suppose we have some changes in history, a couple of commits that we want to get rid of, or we want to re-evaluate what to do. With Git Reset soft, we just move the changes to the staging area. And the changes in the working directory are also there. And the changes are in the staging area. And by the way, these changes are also in your working directory still, so it's preserved. And if it's staged, then the change also appears in your folders. Then we have the mixed reset, git reset -- mixed, which just gives you the changes unstaged. So it's gonna be unstaged and you have access to it. You can stage or you can discard some of these changes, but they appear. With git reset -- hard, the changes are deleted, they are gone. And master is rewinded to that specific branch with git reset hard. Normally, it's not recommended to use git reset hard because these changes are gone. Let's see, let's add two commits, so I'll make some change, doesn't really matter what, and commit it. Then I'll make another change and I'll commit it too. Now that we're done, let's do git reset -- mixed first. So you see that the changes appear in the staging area. So you can see it both in Visual Studio Code and after writing git status. So this is where the changes are. And then you can either commit the changes or you can get rid of them. Doesn't really matter. You can stage and commit them, for example. Now, our changes now appear in one commit. So this reset mixed also works well with squashing commits. So now we have one commit instead of two. Now let's do the git reset -- hard. And we go back to the previous commit. Now remember, we only have one commit now, not two. So don't write #2 because then you would get rid of some other changes you don't want as well. And you can see that these changes don't appear in the staging area anymore. And you can also see that master got also reverted to the previous state. So this means that our changes are gone. They can be recovered from the reflog. So that's still something that saves us. But besides that, there is not much we can do. Let's now learn a simple technique for illustration purposes. It's called cherry picking. Cherry picking is a tool that helps you move a commit from one place to another. So let's say that we start developing a feature, we check out a new feature branch, we make some small changes, and we're done. We make some other changes, for example, we add the copyright notice to the bottom, And we're done with that as well. So we added a copyright footer, and now we add a third change, for example, whatever it is, doesn't matter. And let's suppose that we need this copyright badly on our master branch, and we need it right now. So then what we can do is we can check the commit hash of that specific commit, the copyright commit, and we can write git cherry pick and then the commit hash. And this will duplicate the commit from that branch. It's gonna move it to the master branch. Basically, that's the idea of cherry picking. It's not best practice, by the way. So the reason why it's kind of problematic is that you just cherry pick a random commit from a random place, and then you move it to a different place. And at the end, these different branches where the commits get duplicated will be merged anyway, so it doesn't really make sense to have that. So workflow-wise, it doesn't really make much sense to do cherry picking, because in the end you will update your new branch anyway, and you'll update master anyway. But in very rare occasions, you just cannot move on without a change. So for example, if this was not a copyright notice, but something more important, then you would not be able to move on, you would be blocked. So why not just cherry pick that change on which you depend right now and just continue development? This way things would work out more or less well. Now the problem arises when you just cannot be sure that the cherry picked commit doesn't depend on something else that's before that commit in the other branch. So this way cherry picking is not that bulletproof. You could also branch off from another branch. So for example, instead of cherry picking, you can label the commit that you want to cherry pick with another branch name, and then you merge that branch name or rebase that branch into your branch, and then you would branch off from there. That would also work, although it's not best practice either, because then you would place a dependency on deploying all the previous commits, even work in progress code, and you would not be able to deploy your branch from that. So this is why placing a dependency on another branch is not a good idea, and cherry picking is a better idea in this situation. Because if you cherry pick just that one commit and it doesn't contain any work in progress code that you don't want to deploy to the live system, then you're only responsible for making sure that that one commit is working fine. While in case of branching off from multiple changes, you might have the problem that you have some work in progress code in that branch in the history, and you're just blocked from deploying your change. So this is one use case for cherry picks. Obviously, once you need to merge the changes, you will find that the commit is duplicated. So let's just merge all the changes back to master, and in the other branch you have to rebase master into that branch, just like what we did previously. If there are conflicts, we fix the conflicts, and then after the history got linearized, we just move back to master and merge the other branch. So we're done with these changes as well. And notice the cherry picked commit. You see that actually the commit wasn't even duplicated in history because Git figured it out that it's the same commit. Now that we have introduced cherry picking, we can use cherry picking for a completely different purpose. And this is gonna be the interactive rebase. Without cherry picking, it would not be easy to introduce that, of course, because it depends on cherry picking. With rebasing, you have already learned that it's possible to rewrite the history, because we change the order of commits in history. You can have a later commit before a previous commit when it comes to the timestamp of the commit itself. So now with cherry picking multiple commits, you can reorder your commits with interactive rebase. You can squash multiple commits into one, and you can even remove some of the commits that you don't need. So let's do the interactive rebase on master. We can do it by writing git rebase -i Or you can write --interactive if you prefer that, but -I will do. And let's specify how many commits we want to include by writing head, tilde, and the number. So now you see that these commits appear on screen. And by default, we're gonna pick all the commits. So P stands for pick. You can see the commands on screen. R stands for revert. This means that you use the commit by keeping its commit hash, but you edit the commit message. So if you had a bad commit message, you can very easily just revert that commit by changing its commit message. E stands for edit. So you use the commit, but you stop for amending some changes. That's also possible because you might delete some commented code or do something that would clean your history up. So for example, imagine that you're creating your online portfolio, and after a few weeks you figure out that my Git history is a mess. No problem, you can clean it up. And you can rewrite the history so your potential clients and potential employers will not even see what you did in there, in those commits, because they are cleaned up, the commented code are gone, duplications, bad code formatting, and so on. You can change all these things. But then you might have consequences. So for example, if you reformat all your code, then you might have to fix quite a few merge conflicts, because Git doesn't understand that it's just formatting. Git just figures out that there are some white space changes on some of the lines, and then it asks you to merge or rebase those changes. There is S standing for squash. So if you squash, you meld the commit into the previous commit. This means that the two commits will become one. One of them is going to be squashed, the other one is going to be picked, for example, or you can also revert it. Reverting makes actually sense because if you have two commits, then the commit message might change. So the contents are going to be squashed into one commit. Fixup is like squash, but the commits log message is discarded. And it's also possible to run some commands with exec, the X. But that's advanced. You hardly ever use it in regular scenarios. So let's just stick to these basic commands. And you see that we pick these commits. If you want to reorder them, no problem. You can just select a line and move it to another line. You can do that. You can also squash two commits, and you can also delete some of the commits. But you can just delete the line belonging to the commit, and then the interactive rebase will take care of the rest, and it will not include that commit. It's going to be gone. So for example, if you have duplication, maybe due to cherry picking, then you can just delete that duplicated commit. And basically that's it. After running the interactive rebase, you can see that everything is working as expected. So the end result will map what you saw in the interactive rebase instructions. So this concludes Git. You now know how to do most of the situations that you need as a software developer, including branching, merging, interactive rebasing, squashing, a lot of things. So with this, you can become a full-fledged developer. The only thing missing is that we haven't learned how to create a remote repository, how to clone it, how to upload our content to a remote repository, how to fork someone else's work, how to link your Git account with your GitHub, and so on. So these topics are still missing, and of course at the end I will show you how to upload a resume or a portfolio site based on someone else's template as well. So let's get started with GitHub. I assume that you can fill out registration forms. So if you go to github.com and you sign up for a new account, the only thing that you need to pay attention to is that your GitHub account email address should be the same as what you added in the config at the beginning of when you just started working with Git. This is because we will have to link our Git account with our GitHub account. After the registration is complete, you have to confirm your account with an email. I think it's also something that you can do. You can just check your email address, press the button, the only button that's on the email, and then just validate your GitHub account. Now comes the interesting part. So we have to prove GitHub that we have the right to add repositories, make changes, and so on, so that our email address is ours and we can control that GitHub repository from our computer. The problem is cryptographic. So this means that we need to add a public and a private key to our computer where our Git repositories are stored. We can do this by writing SSH keygen with a dash in between, -t, RSA, -C, and then your email address. You can check your RSA key by typing cat ~id_rsa.pub. That's gonna be your public key. That's why the extension is pub at the end. And you might have created your RSA key in a different folder. It doesn't really matter. In that case, you would have to add that key. Most important thing is that your configurations should store that information. Now you go to GitHub, and in your account settings, so you check your account settings, the settings of your profile, there is an SSH or GPG keys section. You click that, and in there you add your SSH key by pasting it. So whatever you might manage to display on your terminal with cat, you're gonna be able to copy paste it, and now that you've done it, your Git and GitHub accounts are linked. Let's now create a GitHub repository. You can find the button for creating a new GitHub repository inside your repositories. It's the new button. It's even green, so it's very easy to find it. And then you have to name your repository. There is an optional description. And to make your life as easy as possible, don't add the README, don't add the gitignore template, and don't add the license either. Because if you don't add anything, and you create the repository, then after pressing the create button, you will see that there is absolutely nothing in there, no files. And this way, GitHub will give you some instructions on what to do. Given that you already have a repository, you don't have to go to this git init, git add, git commit, git remote add origin, and so on route, the first one. But instead, you can just do the second one on Git. It even tells you what kind of commands you need. So first one is git remote add origin, and this will add the origin to your local Git repository. Let's copy paste it and try it out. It's working. And then you will do git push -u origin master. Pushing is uploading changes from your local Git to the global GitHub repository, for which GitHub provides a web interface. So GitHub is a web interface for a repository that everyone can access, assuming that they have the keys or they collaborate. And Git is your local repository that's sitting on your computer. And push uploads files from Git to GitHub. I said files because the Git history, the commits, the configuration, they are files as well in your .git folder. You remember, this is what we discussed at the beginning. For most of you, Git push should work. If you're following this tutorial from a computer where you had another Git account already and keys and everything else, it might happen that you're logged in with another Git account and you messed up the private keys and public keys. If you have this problem, then what I would suggest is that in your GitHub repository that you just created, go to the settings, and inside the settings there is a collaborator section in the manage access. So in the collaborators, you can invite a collaborator, and then they can confirm it with their own email address. And after the confirmation, the collaborator can also add changes to your GitHub repository. They can just collaborate with you. By the way, GitHub is for collaboration, so most likely you're gonna have other people who will work with you. Not always, but oftentimes it's the way to go. So now that the pushing is complete and you might have decided on adding some collaborators, now let's see what's on GitHub. So we're going to our repositories. You can see all the files and folders that are in there. If you click on a file, you can see the changes. You can see the current state, and you can also blame. Blaming, it's one of the main human features that I wish didn't really exist, but the world would be an easier place without blaming. But technically, in GitHub terms, this is quite a useful feature, because if you check blame, then you can see who authored that specific commit and when. So this way you can trace back to where a problem or a bug got inserted into your code base, and you can follow it up with that person. The problem comes when a person leaves the company and their GitHub account becomes a ghost account. That can also happen, because then you will not have the history anymore. In this case, sometimes you can still follow these things up, because most of the time the author of a change or the author of a file is checked in to a Git and GitHub as well this way by adding a signature that this is your email address, for example. So this is a defense against ghost accounts. You can even click on a commit and you can see the changes. Greens are additions and reds are deletions. So you can check that too. And you also have a history, by the way, where you can see what kind of commits influenced this file in the past. And you can even check the commits one by one by clicking on the commit hash. Here you have the first 7 characters of the commit hash. And you can also time travel back to the time when this commit was added, so when this commit became master, by clicking this browse this repository at the point in the history. So it's also good for time traveling. You can also create issues. Let's create an issue. For example, we want to add a very important paragraph to index.html. We have seen this issue over and over again. By the way, in the issue you can create any Markdown text that you want. So the format is Markdown. It's a very easy format. I've written all my books in Markdown actually most of my books, because one of the editors forced me to write this online Microsoft Office 365 or whatever. The issue with that was that it was not ideal for collaboration. So if multiple people start commenting, and especially if it's hosted online, because it has happened once that I started writing my changes, but the autosave was triggered by my change, and saving took 6-7 seconds, and by the time saving finished, I lost whatever I typed. But then I continued typing, and then other save changes were triggered. So it was a nightmare to work with that. I had to work remotely and push the changes back, but it was just not meant for collaboration back then. So Git and GitHub, you see the beauty, it's just commits, pushes, and merges. So you can just merge changes of others. It's very easy to track what the history is. This is one of the powers of Git GitHub, or GitLab for that matter. So if you're interested in a GitLab video as well, write in the comments below, after smashing the like button of course, and I might upload a GitLab video as well. Same holds for a Markdown tutorial, although it's kind of self-explanatory. So you just go up to dillinger.io, and there you can see an example Markdown file, what it looks like, how to write Markdown, how to write unordered lists, how to include links, how to add headings, and so on. You can learn it in 5 minutes. Alright, getting back to the issue, we'll have to develop this very important paragraph change. Let's do this development in the usual way first. So git checkout -b feature important paragraph, and then let's add the paragraph to our index.html. And once we're done, we do the usual things. So we stage, we commit, and now after the commit, there is an other mandatory thing that we need to do, the push. We only learned how to push to master so far, and this is a valid workflow as well, that we merge the changes back into master by going git checkout master and either merge or rebase the change, the feature branch. And now, after we merged things back to master, we can push the changes to origin, master. Notice that the -u switch is not there anymore, because the -u was originally responsible for setting the upstream. This was just in the first time when we had to establish tracking between the local repository and the remote repository. Now there is no such thing anymore. So we're set and the changes are done. If we view our GitHub repository, you can see that the changes appeared. Now let's pretend that we made a typo and we had to add another sentence in the paragraph or something. So let me make that change as well. So we're reviewing things. And now we know that we have fixed the problem. I'm just going back to the feature branch, git checkout feature branch, and now I'm gonna add this change as well. And notice the commit message after git add. So git add dot, git commit -m, and then in the commit message I describe the change, and afterwards I'll add fixes #1. Fixes #1. Let's see what this does. Let's go back to master. Let's add our changes. And now let's push origin master and let's see what happens to the issue. So in the issue, both comments appeared. And after the second commit, you see that mysteriously the issue got closed. Whenever you write fixes, a hash mark, and the issue number in a commit, it closes that issue. And if you just reference the issue, so even in the first commit there was a reference to that issue, then it also appears in the log, but it doesn't close the issue. I will correct myself a bit. So far we only uploaded changes to the master branch of GitHub. If you add fixes, hash mark, and the issue number, then it only closes the issue if the commit is there on master, on the master branch. If it's added to another branch, it's not working like that. It just adds the commit reference and that's it. This issue number 1 is closed. Let's add the second issue. And this issue is gonna contain another very important change. In fact, this time we could just use GitHub instead of Git to do the commits. We can do that too, so we don't have to necessarily work on our local computer, it's just advised. So I'll show you technically what needs to be done to work on GitHub, to create branches, commit changes, and so on. So you see this branch dropdown where we have the master. This is not the local master on your computer, but the remote master on GitHub. And there, if you type a new branch name, for example, we'll create a branch name for this feature, then you can see that GitHub offers to create this branch for you. Let's do that. And after that, we can switch to that other branch. So here you can see that we're on this other branch. And let's click a file. And inside that file, you can see this pencil icon for editing this file. And in the edit, we can simply add other paragraphs. We can add multiple commits, by the way. The problem with GitHub is that we make one change per one file and then it already asks us to commit it at the bottom. But anyway, let's add the second paragraph. And in the commit changes part, let's add a message. And inside this message, let's add the word fixes and then a hash mark, then the issue number. Let's commit the change. You can see that the commit is made on the test branch. So let's go back to the issue. You can see that the commit is linked to the issue, but this commit doesn't close the issue. Let's go back to the code tab, so the first tab, and you can see this compare and pull request button appear on this yellow window where you can see the new branch and there was a recent push. When we compare changes, it's basically a review. We call these to be reviewed changes pull requests. So we'll press the compare and pull request button, and afterwards it enumerates the commits, and if you prefer, you can review the commits individually. In fact, it's recommended that we review the commits individually. There you can see the changes one by one. You can even comment on them. and then you either accept the changes or reject them. Here you can also use Markdown. Obviously, if you don't have privileges to approve changes, then you can just comment. If you're ready with the approval, then check out this Rebase and Merge button. You can do create a merge commit, which means all commits are merged from this branch via a merge commit. So this means that you will get the history, the previous master history and the previous branch history preserved, and a new commit is created that joins these two histories. The second option is squash and merge. We have seen that too. So we squash all the commits into just one and merge it. And the third one is rebase and merge. So this rebase is gonna make the history linear. This means that we apply the changes on top of each other. Let's select this rebase and merge this time. And then we have to confirm it. And after we're done, the pull request is successfully merged. Then GitHub offers the deletion of the branch, which we can do either now or later. So you see that GitHub offers the same functionality that we went over on Git. But bear in mind that GitHub is not a substitute for Git. It's very important that we do work on Git and not on GitHub. GitHub just happens to have a similar functionality for administration and reviews and so on, but even the review is usually done on your local computer, pulling the changes and testing them in real life. So you don't just read the changes on GitHub, except when we're talking about documentation, but you also test the changes. So you run the application on your computer and check out the code on your browser or on your computer, depending on what kind of code you're writing. Let's go back to the issue, and you can see that after the rebase was made, the issue got closed via the commit that ended up on master. This is because of the fixes, hashmark, and the issue. So we're done with closing the issue. Let's now check what we can do if we have conflicting changes locally and we want to pull the changes from remote. So for that reason, let's make some changes to the same file that will eventually conflict with the changes. We're adding a paragraph, and we can commit safely because it's our local repository. And after the commit, we cannot push, obviously. So if you do git push origin master, the push will be rejected because master already contains changes and we have to pull before pushing. So let's do exactly that. Let's pull. And after the pull, you see that there is a conflict appearing. And here we have to resolve the conflict. So after the conflict resolution, we have the same merging or rebasing type of problem. Most important thing is that we have to see the remote master end up in our history. So if you use gitk, for example, or Git Log or Git Log graph one line, you have to see the origin/master appear in the history as a label, and then you can push the changes. Here we push directly to master. Normally we push to other branches. So I should have developed the piece of functionality, and technically I could push that other branch as well to remote, but after merging this change back to master, sometimes we just push master to GitHub. There are many different workflows. There are cases when we don't even push anything to master because it's done automatically for us, or the merges, the pull request reviews are done, and this is what makes the commits end up on master. So there are many different workflows, but here let's just accept that normally we don't make changes directly on master. Few exceptions could apply. For example, a very important, very urgent fix where your company is losing millions every hour or hundred thousands of dollars every hour. That fix can also end up on master directly. But normally we work on branches. But bear in mind that master is just another branch. So we can very simply just commit and push master, and then origin master will track the changes, and you can see these changes in the Git history. So you go to code on GitHub, and there are these commits. So you click the commits, and you can see the changes as well. By the way, in the code tab, there is also the branches. So in the branches, you can see what branches you have, where they are with respect to master. So for example, 2 commits ahead or 5 commits behind and so on. So you can see that too, and whether they are merged into master. If they are merged into master, we can just delete them with the trash. Let's do a scenario when we do a proper workflow where we develop a change in another branch. So we create the issue as usual. We describe the changes. And once the issue is created, we go to Git and we perform the fix. So here the fix is easy. Obviously, I'm not entertaining you with some complicated algorithmic fixes. It's just editing an HTML file. But once the fix is done, we go to our feature branch, check out a new feature branch, stage the change, commit the change. And once the commit is done, we need to sync up our local branch with a remote branch. This can be done with git push -u, origin and the new branch. After typing git push -u, origin and the branch name, the -u flag makes sure that tracking is established between the local branch and the remote branch. This is an upstream setting. If you go back to GitHub, you can see the results again. So you can see that the remote branch got created. You can even go to the remote branch, and you can even merge the changes as pull requests. So we have talked about a lot of things. Maybe there is just one thing that we haven't explored. It's Git tags. So it's also possible to add tags to the release. Oftentimes it's automated, so this means that if you have a development team and that team has a lot of developers, oftentimes it makes sense adding either version information to our Git GitHub history or timing information, for example, when some changes were made. These tags can be generated either automatically or added manually. It's the same thing because these are Git commands executed on the command line, and this can be automated sometimes. So we add git tag to add a new tag and add a version, for example. So git tag v0.4 adds a version 0.4. You can also do git tag -a, version 0.5, for example, -m and some message. So a tag can also be annotated. If you have a message, it's an annotated tag. The other tag is called a lightweight tag because it doesn't have a message. You can show versions. For example, git show v0.5 shows this version 0.5. And it's also possible to push tags. For example, git push origin v1.0. This is gonna be in remote. Or you can also add git push -- tags to push all your local tags to remote. You can also add the tag to a past commit. So for example, a git tag, then you add the tag name and the commit hash. What is more, you can also create a new branch belonging to a commit that has a tag name. So it's git checkout -b, this is the command for a new branch. Then you add the branch name that you would like to see, and then you add the tag name. Tags can also be deleted, so we have git tag -d and then the version, or if you like typing more than git tag -delete. And you can also push these deletions, so git push origin -d will do the trick, or --delete will do the trick, where you delete a tag. Or you can also use the colon, so git push origin, colon, and then the tag. Multiple tags can be enumerated, so if you have 2 tags to delete, then you can add them space separated. So that's it for tags. They are also useful. They also appear on GitHub. In some companies you see them. I'm switching GitHub repositories now because now we're gonna host a portfolio site, and the easiest way to host it only works in case of one repository, and I've already made it once on the GitHub repository that you could see so far. Now is the time to go online and find some free templates for a portfolio site or for a resume site that we can just slightly modify and host online for free. How would that sound? What we know so far on Git, GitHub and basic HTML editing with Emmet is sufficient for us to go online and find a portfolio site and just modify the text and the images. So let's see, I made a search free Bootstrap portfolio templates. And you can see that, for example, here there is a freelancer portfolio, there is an other one. You have these 6 basics, so you can use any of them. Well, if you go further, you can find many others where they are even more stylish. So, for example, there is this Studio, Felix Premium. Then you would go to more info. And all you do is just change the images. Well, this is not free, so I don't know why it appears as free. But many of these templates are actually free. These two are definitely great ones. This is an agency, creative, grayscale, stylish portfolio. And let's say this Theme Fisher as well. So here you can see some other portfolios. And then let's suppose that you really like one of the websites, like any of them. These are just templates. These are not necessarily portfolio sites for you or resume sites, but we will also get there too. So let's suppose that we really like this. Let's go to details and preview. So on the preview, you can see the template itself, Theme Fisher, Fame. And you can see what it looks like. So you can make these changes. Obviously you can supply the data, you can do a lot of other things, animations and so on. And if you would like to use it, then this is a Bootstrap 3 template and I think it's for free. Free version, free pack, no documentation, no support, limited downloads, only personal use. So obviously if you have a business it's not gonna work. For that you would have to pay. But there is a free download. And then you download the files. And then you can host it on GitHub in the same way how you have already hosted your application. There are many theme sites, by the way, so Theme Forest, Theme Fisher, and so on. So you can see a lot of places where you have hosting. Now we're gonna go back to this basic site. So there is a portfolio site that I would like to show you, and there is a resume site. And you can see that it's not only operating on a download basis, but you can also view it on GitHub. So if you would like to see this portfolio site on your computer, this is a very common one. You might need to change the colors or at least something so that you make some changes to it. There is even a name, email, and so on. So you might not want that actually on your computer because you don't yet have a service that gives you a contact option. Although you can link this website with FormSpree as well. So there is this service called FormSpree that collects these form submissions that you could see at the bottom. So you can see that this is a portfolio. You could use this, but today we're gonna use this resume site. Check out the live preview. You can see that this is a resume, and you can also navigate with some scrolling. It looks like that it could be a bit hard to customize it because, for example, you might think that you need this circular image to place it in here. But no, just look at this. If we right click and open image in new tab, then you can see that the profile picture is actually a square one. And I think that you have a square picture on yourself. All this is done in CSS and you don't even have to know how it's done, because as long as you're satisfied with the colors, all you need to do is change the names, the text, and so on. The LinkedIn links, GitHub, Twitter. Maybe if you don't want to show your Facebook, then you delete your Facebook and that's it. So let's see how we can do that. We go to GitHub. So view on GitHub. Then after viewing on GitHub, we can do clone or download. That's one option. So we can clone this GitHub repository locally, or we can download it as a zip file. There is another option that I wanted to show you. It's called forking. A fork is basically a copy of this start bootstrap resume, and this is gonna be hosted under your name, your repository. You can do that because of the license. So you see the license here. It says MIT license. That's one of the most permissive licenses that you can have. You can freely modify the template and upload it. You're gonna use a resume template for personal use anyway, so why not? You can do that easily. So we press fork, and after pressing fork, you see that there is a process forking start bootstrap resume. It should only take a few seconds, and we're done. You see that now it's under my GitHub repository. This is mine, and then start bootstrap resume, forked from BlackRock Digital start bootstrap resume. So we have the files, and we have the full commit history of the other people who, or was it developed by one person? We'll soon see. It looks like it, so it's only David. No, actually someone fixed a typo, but it's mainly David who developed this resume. And now we're very close to actually hosting it online. We're very close to it, and I'll show you how to host it right now. All we need is we have to go to the settings and change the repository name from start bootstrap resume to our GitHub username. In this case, that's the GitHub username. So copy, paste, dot github.io. You can see that the repository is now available. Let's rename it. And now we're done. That's all we need to do to host the repository, because the rest is done by GitHub itself. You can see that when we open the branches dropdown, there is a GH Pages mysterious branch appearing. This is automatic and it's done by GitHub. So this GH Pages is a branch that is created whenever your repository name is your GitHub username .github.io. And that's it. That's all you need to know to be able to host a repository. We can also see it by selecting it, Ctrl C, and instead of this BlackRock Digital, we can do Ctrl V, and it's loading, and you can see that the same website is now hosted on this domain. So I just loaded it and it's the same website. Let's make some changes. So to make changes, I will illustrate this by cloning the repository. For cloning, you will need to open this dropdown. It looks like a button, I know, but it's a dropdown. And then you can just select the cloning option. But before that, there is a chance that, or there is a small chance that you have an other GitHub username. In my case, I told you that I went to this user because I wanted to demonstrate this hosting, and obviously I couldn't host on my own repository that you saw before, simply because there is already something hosted there. So in this case, if you wanted to manage the hosting from another repository, then you do manage access, invite a collaborator, and then search for the user. Yeah, it's this one, and let's add the user to this repository. There is a pending invite. I will have to approve the email. I'm gonna do this on my other computer. Just got it. There is a view invitation afterwards. I will show you my email invitation. It's here. So you can see the invitation appear. So you can see the view invitation. We can click on the view invitation and then we can accept it. And now we can collaborate with this other repository. This is because I will continue using this other GitHub repository on my computer. So you see that it's still awaiting response, but now I'm a collaborator on this other repository. So this means that I can clone it and I can push changes to it. So let's continue with the cloning. Let's try cloning with HTTPS. So here we have a Git link we can copy it, and then we can get a new Visual Studio Code window here and type Git Clone, that's cloning, and we just paste this Git file and press enter. Cloning into, and then there is a folder where we're gonna clone into, and you can see that the folder got created. We're receiving the objects, resolving data, and so on, and then we're done. So now we're inside this folder, we have all the files. We can also move into the folder, so we just type prog. It's not case sensitive, so you don't have to do it in an uppercase way. You see that after tab it autocorrects the P to capital P, and you can also see that we are on master right now. So we have index.html, and let's see the name of the author, Clarence with A. Let me search Ctrl F or Command F in Mac for Clarence. So we have a couple of hits, and you can change your name as well. So I will change mine. There you go. And you also have another Clarence here, and I think these are the only occurrences. And no, changing names is not hard, even if you don't understand all these things. So you have divs, these are HTML tags, sections are also HTML tags. This is a simple CSS class, and these are Bootstrap dependent classes. Basically, dflex means that it's a flex box, display flex, added by Bootstrap, and so on. So once you learn Bootstrap and once you know how to modify these classes and what to do, then you will know how to edit them. And obviously you can change your email as well. For example, I'll change mine, info, so like this, and you can change it there as well, so that it's also displayed like next to the anchor tag, so inside the anchor tag to be exact. You can change your address. You can change a lot of things, basically all the text. And let's pretend that we don't need this web design intern paragraph because it doesn't apply to us at all. Let's delete it. Done. What's important is that it should be well formed, so I'll get this change back. And if you want to make sure that you deleted something properly, then make sure that you close it. You see on the left next to the line, you have this open close opportunity. And here you can see which divs belong together. So this is the opening and line 138 is the closing div after we closed it. And here you can safely delete this because you don't mess up the internal structure of the HTML. So this is the way how these divs are working. By the way, back in the days, I had the privilege to work with a client who supplied us HTML in such a way that they used Microsoft Word to edit a document, and then they saved it as HTML, and they had all these different tags, and they thought, we need this paragraph on. Okay, it starts with university, so let me copy it like this, and let me finish the copying here, like 2010. And then they submitted this to us via an online interface. It was a content management system, and this content management system automatically inserted these changes to the website, and this means to us that it was immediately visible on the environment. And then they sent us the bugs that the website is not working. What's the problem here? Obviously that here this H3 that we close inside the highlighted part was never opened. Whatever you open, you also have to close. So be very careful when deleting text, because, for example, if you don't need this resume content part, then you click here, you close this, so lines 140 to 145, and this is the open part, this is the close part, and you delete it like this. So be very careful with the deletion in HTML because you need to delete the open tag and the close tag. And by the way, if you don't want to display your Facebook, for example, then you have this FA Facebook. This is the only occurrence for Facebook. So you see that there is not even a link added. So what you would need to do is check out your LinkedIn, for example, and paste your LinkedIn link here in the href. href equals hashmark. You paste your LinkedIn link. But you will figure this out as you go and as you use the website. And you can see that there are no other Facebook links anymore in the application. Let's see one more thing. There is this images and profile.jpg. So we could either find where the profile.jpg is and replace it with another name, or we could just overwrite this profile.jpg file with one of our images. To view the changes locally, let's go to right-click, reveal in File Explorer. Technically we could do it in easier ways with some plugins, but let's just use this. Double-click on index, because that's our HTML file, or just drag and drop it to a browser. And let's see the changes. It's here. So you see that the name is changed, the Facebook is gone, email is changed, even on the bottom left you can see that the mail to link is changed, and the rest is still working. We deleted the paragraph, doesn't really matter. Let's change this image. I've prepared an image that I'm gonna use, and we just need to go inside the images folder. You can see that there is this profile.jpg. This was the original image. All we need is overwrite it. So in Total Commander, I'll just use F5 for copying, and this will overwrite the image if I add profile.jpg. But I think you can copy paste files. So you would need to delete it, copy it, and rename it to profile.jpg. That's all we're doing. Yes, overwrite the file. And now we have the profile.jpg file here inside the github.io page. By the way, you can also rename it. Even in Windows Explorer or Finder, right-click and then you rename, and then drag and drop it to the other folder. So it should be easy. If not, let me know in the comments and I might create a video on this. So you can see that the change was made. Obviously, there is a problem with this ellipse because my image is not rectangular but rather oval shaped. So you either find another image, or the other option is that you find some painting software or something. I know Microsoft Paint, feel free to laugh at it. So we can just crop basically by selecting some parts of the image like this. Right click, crop, file, and just save. So we're saving the profile. Now the image changed a bit. Reload, and now it appears more circular because we created a square shaped image and not a rectangular one. And the rest is taken care of by CSS. So we're done with all these changes. We only need to add the changes. So Git Status, let's see what's here. Modified these like index.html and profile.jpg. Git add dot, done. Git commit -m, resume, customization, done. And here we're not even bothering with creating other branches because, you know, here I'm working with myself only. So this means that I don't need to branch off or do concurrent feature development or bug fixes, because here I'm just working on the website. So let's make things as simple as possible. Git push origin, git push -u origin, master. So we're done. Commit is there, push is gonna be there, hopefully soon. And now that we have pushed to master, The interesting part about this GitHub pages is that the GitHub pages branch is automatically refreshed too. So now we are on master. You can see my changes from 1 minute ago. And if you go to GitHub pages, then it should be updated too. And as I refreshed the page, you can see that all the changes went live, including the image. Well, that's not the best image that I could place in there, but still it will do the trick. And also the name, email address, Facebook is missing, one of the paragraphs are missing, and then you can change these logos. You can do a lot of other things in here. So it's that easy. So I have seen many of these online marketing people, so doing sales pages of products, not necessarily drop shipping, but it can also be you find a product and you sell it on Amazon, for example. And most of them go for WordPress and PHP. And then, given that they don't even know what HTML and CSS are, like they don't even know the basics, they can just use Elementor, for example, or some other tool. And the issue is that they don't understand how websites are created. It's that simple. You can also look for sales page templates, and you can also customize, modify the sales page templates directly in source code. And even though it takes another abstraction level, which will take a bit of time to learn, but then you will get full control. And while those people will continue suffering from the limitations of this drag and drop way of building their websites, you will be a lot faster, and your sales pages will look a lot better eventually. So this is a good way of doing things. It's also faster because you don't have to load all the junk of the PHP-based WordPress. In case of a simple sales page, you don't need a whole WordPress ecosystem or anything, and you can still build your shopping carts, you can still build everything with even with Bootstrap. I'm not saying that Bootstrap is an optimal solution, but you can see that within a few minutes, with a few clicks, all you need to do is edit the common sense text, change images, provide content, and the structure is provided for you. And there you go, resume site. So this is why it's important to learn Git and GitHub, that you know what is going on and how you can create useful websites fast. So that's one use case. The other one is that you can get hired for even a 6-figure salary, of course, but not as a website developer, but a web application developer. And you can also collaborate with other people. There is no epidemic in the world that can stop you from collaborating remotely. And if you wanted to contribute to even React or some other repository today, you would be able to do it with GitHub. You would just submit your pull requests, and they might consider accepting it if the pull request is good. How can you make sure that your pull requests are good? Maybe that's the last thing that I'm going to show you. Pull request for beginners. So there are some ideas. Awesome for beginners. Maybe pull request ideas for beginners. Maybe that's better. Documentation mainly. GitHub pull request tutorial, that's a bootcamp, yeah. Yeah, there you go. I now can find what I was looking for. First timers only. They created this blog post, how you can start doing online contributions. And they say there is this first timers only list that will get you started with online pull request submissions. And as you contribute to open source sometimes, from time to time, you can either establish yourself as an authority, just like many other people who contributed to frameworks, libraries, and so on. Or you can also improve your application package, because some people say that GitHub is the new resume, even though it's not completely true, because there is still HR and still internal recruitment, and these recruiters sometimes don't know what they are talking about, mixing Java with JavaScript, or being a bit too pushy on LinkedIn and so on. So I can see some wave of automation filtering some of the incompetence out. But in software development, regardless of what kind of recruiters we're working with, GitHub open source contributions help. So that's one thing. The other thing is that you can build on top of other people's work and create your own thing. This is what, for example, in the different coin ecosystems happened. So for example, Litecoin instead of Bitcoin, you know, or Bitcoin Cash instead of Bitcoin, and so on. So all these projects started as a forks, or Preact started from React. There are endless opportunities to contribute to the ecosystem, and other people will sooner or later get to know your work, and this is gonna be useful for you. So that's it for Git and GitHub. I hope you liked this video. Don't forget to smash the like button. And I'm happy to branch off from this tutorial and shoot some videos on some tangent topics. So if I didn't cover anything, let me know in the comments below. And maybe I will create a video on your topic. If you haven't coded along with me, then now is the time to go back and do it step by step. I can only encourage you to do it because Git and GitHub will be super important for your future. By the time you master the skill, you will not even think, oh, was it git push, was it git pull, was it git commit, and so on, or what is this command good for? You will just know what's going on. This is the skill level that we're aiming for, so good luck for that. Review the material, do it multiple times because it pays off. Good luck.